Welcome to Beyond the Comfort Zone Talking Shit with KING-KAMBUF. I am so ready to get tactical today because the material we are about to dive into is, well, it's not about pretty pictures. We're looking at the architectural insights with KING-KAMBUF, specifically the daily interdisciplinary mentorship brief from Saturday, December 20, 2025. And this thing is basically a playbook for professional power.
It absolutely is. This is not your typical design discussion. This deep dive really pushes us past form, past aesthetics, and into the fundamental systems that actually shape the world we build. And according to the services of KING-KAMBUF P.S. Architecture and their daily mentorship digest, we're looking at this through two, let's say, profoundly critical lenses.
Exactly. Two huge lenses. The first is what they're calling architectural statecraft, which is all about how architecture is shaped by, governance, by how much risk an institution can handle, and this is the big one, by contracts, the delivery mechanism.
And the second lens is thermal resilience. This is the hard reality of the climate crisis. It frames architecture as a field being tested, really tested, by these massive planetary forces. This is the survival mechanism.
Right. So you've got delivery and you've got survival.
And the foundational thesis, and this is really the key takeaway for you, the learner, is that how a project is procured. It fundamentally determines what can actually be designed. And at the same time, we have to grapple with the fact that extreme temperature isn't just background noise anymore. It is a lethal, deeply inequitable design driver. It has to be part of every single calculation.
Okay, let's unpack this. We are basically charting the collision of two massive forces. On one hand, you've got the fine print of the contract, and on the other, the raw physics of a world that is just getting hotter. So let's start with statecraft, because, if you can't navigate the contract, your best design is just a drawing. It will never, ever get built.
Never. That's the perfect place to start.
Okay, so this first segment is all in on mastering these power structures that are, just baked into how projects get delivered. And the brief is really insistent on this point, that the skills we used to think of as back office.
Right, the boring stuff.
The boring stuff. Contract negotiation, risk management, even just understanding the legal side of things. They're saying these are now absolutely mandatory if you want to have any design authority at all.
It's a huge shift in mindset, a critical one. You cannot be a great designer today if all you do is focus on the sketch. You have to understand that the systems that deliver the building, the procurement, the contracts, they are what define the final piece of architecture, which means, and this is so important, the contract documents are just as critical as the construction documents. Hashtag tag 1.1, the global shift in project delivery.
All right, let's start with the industry pulse signal from the brief. We are apparently seeing a worldwide systematic move away from the old design bid build model. GPK.
Traditional way.
Yeah, the traditional way. And it's particularly public agencies leading this charge. So my question is, why? Why is this old linear way of, you design it first and then you bid it out? Why is it suddenly being pushed aside for things like design build or CMGC or alliance models?
It's a great question, and the source material is very, very clear on this. The drivers are, well, they're complex. It goes way beyond just speed. Everyone always says, oh, alternative delivery is faster, and it can be.
Sure.
But the core motivation, especially for a public owner like a city or a state, is strategic. It boils down to two things: risk redistribution and ensuring political accountability.
Okay, let's dig into that risk part. In a traditional DVB world, when the design is done and it goes out to bid, who's holding all the risk?
The owner is. Almost 100%. Think about it. If the design has flaws that make it hard to build, if the market for steel suddenly spikes and the bids come in way over budget.
Or if the contractor starts digging and finds, an old forgotten subway line.
Exactly. Unforeseen conditions, massive change orders, all of that financial and schedule burden falls directly on the public agency. And that leads to cost overruns. For a public project, a cost overrun isn't just a budget problem. It's an immediate, massive political liability.
Right. It's a headline. Your tax dollars wasted. So political accountability. How does switching to something like design build shield a mayor or a governor from that kind of backlash?
By using design build, that public agency takes all that financial and schedule risk and transfers it. They hand it over to a single, integrated private team, the designer and the builder working together. So now, if the project is late or over budget, which, let's be honest, happens all the time with big public works, the government can point its finger directly at the design build team and say they are responsible. It contractually shifts the accountability away from the public project managers and onto the private company that signed the guaranteed maximum price. So it lets the government deliver these huge, complex projects with more predictable costs and, crucially, a much lower risk of getting hammered in the press or by voters.
So the contract, the delivery method, is actually an instrument of statecraft. It's a buffer zone between the politicians and the inevitable chaos of a construction site.
That's a perfect way to put it, and that brings us right back to that core insight from the brief. The delivery method is a design constraint long before you ever pick a material or sketch a single form.
Right, because if you're an architect on a design build team, you know from the very beginning that cost is king.
Supreme ruler, absolutely. Your aesthetic choices, your technical ideas, they have to be grounded in what's buildable and what's affordable right now. It's just a structurally different universe from a DBB project, where you have a bit more freedom to dream a little, and you can kind of defer that cost headache until the bidding phase. Hashtag tag 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 1.2 procurement as a staged filter. And this whole political need for predictability and risk control, it's exactly why procurement has become this really staged, very detailed filtering process. The briefing makes a point of highlighting the separation between two key documents, the RFQ, which is the request for qualifications.
And the RFP, the request for proposals.
Exactly.
So why the two-step process?
Yeah.
Why not just put out an ad saying, hey, who can build us the best library for the cheapest price?
Because when you're spending public money, you have to prove competence before you can even consider innovation. That's the logic. The RFQ, the first step, is purely about evaluating capability. It looks at the team's past projects, their financial health, their experience with similar buildings, their capacity to handle a project of this scale. The owner is basically asking, forget your fancy design for a second. Are you professionally and financially stable enough to even take on this risk? It's a pass-fail.
So it's like a pre-screening.
Yeah.
And only the teams that pass, the ones who get shortlisted, they're the only ones who get to move on to the RFP.
Precisely. And the RFP is where you evaluate the solution itself. That's where you look at the actual design idea, the proposed schedule, how they plan to handle technical challenges, and of course, the detailed cost. This whole filtering process makes sure the owner isn't wasting millions of dollars and months of time evaluating these amazing design concepts from firms that might, go bankrupt halfway through the project.
Or have a history of suing all their clients.
Right. It's risk mitigation through paperwork, basically.
And this connects directly to the legal side of architectural statecraft, specifically what Q7 in the brief talks about. Bid protests. It says process errors can legally invalidate design excellence. How? How real is that risk? Does that actually happen?
It happens more often than you'd think, and when it does, it's just devastating for a project. A bid protest is when a losing team takes the public agency to court. And here's the key. They don't argue that the winning design was bad. They argue that the agency didn't follow its own published rules for selecting the winner.
Oh, wow. So it's a technicality.
It's pure technicality. They'll ask things like, did you score all the submissions according to the criteria in the RFP? Was the evaluation consistent for every team? Did the winning team forget to include one mandatory form in their appendix?
So you could have the most incredible world-class design that scored the highest, but if the government's paperwork was sloppy, the whole thing can get thrown out.
Thrown out, or more likely, frozen for months or even years while it's tied up in litigation. I've seen major public projects, cultural centers, transit hubs put on ice for a year because a public official didn't properly document why they gave Team A a 9 out of 10 for community engagement and Team B an 8. The lesson is just so profound. If you don't master the legal grammar of procurement, the law itself can kill your design, no matter how brilliant it is.
So mastering procurement isn't just about winning the job. It's about making sure the job can actually happen.
It is the absolute prerequisite for success in the public realm. Hashtag 1.3 deep dive into progressive design build, PDB, and financial leverage.
Okay, let's drill down into a specific model the brief mentions. Progressive design build, or PDB. It's framed as this big opportunity, but also one that's totally tied to the idea of leverage. So PDB allows for this early collaboration with the contractor, which sounds great for transparency, but the brief warns that it can turn into design capitulation if you're not careful.
It's a fantastic model, really. It's built for transparency. In traditional design build, the contractor gives you a hard price, a lump sum, based on very preliminary drawings. It's a bit of a gamble. But with PDB, you bring the contractor and architect together much, much earlier in the process. They develop the design together in phases, and they're constantly checking it against real-time market costs.
So it's more iterative.
Highly iterative. And the project only moves forward to construction once everyone, the architect, the contractor, and the owner, mutually agrees on the design and the cost.
But there's a ticking clock. The brief calls it the pre-GMP window.
Mm.
And Q3 asks why architects have to understand the GMP. What is the guaranteed maximum price, and why is it such a critical moment?
The GMP is the point of no return. It is the moment the cost assumptions are contractually locked. It is the freeze. Before the GMP is signed, the design team has maximum leverage. The cost is still fluid. The contractor is acting as an advisor, actively helping you refine the scope to meet the budget target. This is the architect's golden window to assert their design intent and get it codified.
And what happens if the architect is just, collaborative but not strategic during this phase? If they keep the language vague, like saying we want high-quality materials, but they don't specify what that means.
That is the exact moment that silent design erosion, which is signal B in the brief, begins. The second that GMP is set, the entire team's focus shifts. It's no longer about optimizing the design, it's about controlling the cost. And any design feature that wasn't legally and specifically locked down before that freeze, it immediately becomes a target for value engineering.
Which we all know is usually a polite way of saying cost cutting.
Usually, yes.
Can you give me a really concrete example? How does this silent erosion actually play out on a project?
Sure. Let's say an architect proposes a really sophisticated, beautiful terracotta rain screen system for the facade during the early PDB phase. But in the pre-GMP documents, they just list it under a general category like high-performance facade, without locking in the specific material or its performance metrics. The GMP gets set. A month later, the contractor comes back and says, look, we're seeing some pressure on the budget. That terracotta system is adding $500,000. We can get you a standard EIFS system, an exterior insulation and finish system, and we can still hit the required R value for the wall.
So it meets the minimum code.
It meets the minimum code. The owner, who is now staring at a fixed budget, will almost always accept that substitution. And just like that, the core design intent of the facade is gone without a fight.
Wow. Which makes that daily drill mentioned in the brief, designing for delivery, so incredibly important. It says the architect has to identify which parts of their design are vulnerable to this kind of cost pressure, things like high-end glazing, complex details, and then figure out a strategy to lock them in before the GMP.
Yes, and the strategy isn't about arguing for aesthetics. You can't just say, but it looks better. The strategy is to translate that design detail into a non-negotiable performance requirement.
So instead of saying, we need these beautiful deep-set windows,
you say, the window assembly must achieve an effective U value of 0.25 below our K, and the maximum allowed solar heat gain coefficient is 0.20, achieved via an integrated external shading element as detailed in drawing A401.
That's contractual language. That's a spec.
It's contractual language. Now, if the contractor wants to propose a cheaper window, they have to prove it meets those exact metrics. And if it doesn't, they're in violation of a performance clause, which is something the owner cannot just wave away.
The lesson is just, it's so clear. If you don't use your pre-GMP leverage strategically, the market personified by the contractor's spreadsheet is going to write the final draft of your design for you. Hashtag tag 1.4 navigating risk, responsibility, and liability. Let's talk about the ethical and legal tightrope here, especially in a design build world. Q2 in the brief mentions this. When the architect is hired by the builder, not the owner, their contractual alignment shifts. So how does that change liability?
Contractually, it's a big shift. The architect's direct legal liability moves from the owner to the builder. The builder then holds that liability to the owner. And a lot of architects see this as a benefit, It simplifies the legal chain of command. But, and this is a huge but, the code life safety bite in the brief provides the absolute non-negotiable backstop.
Which is what?
It's that while you can share or transfer financial and schedule risk through a contract, the architect of record remains legally accountable for life safety compliance. Full stop. That means your legal duty for things like the building code, fire safety, egress paths, structural integrity, that is your responsibility. It transcends any delivery method. It's tied to your professional license.
So let's play that out. The GMP is set. The contractor comes to the architect and pressures them to change a detail that, say, compromises the fire rating of a wall assembly to save $20,000. If the architect agrees, and something goes wrong, that failure lands squarely on the architect's license, even though the builder demanded the change.
100%. The contract might assign the financial risk of that change to someone else, but the professional responsibility for the safety of the people in that building remains fixed with the licensed architect. Ethically, you have to be willing to draw a line in the sand, to issue a formal warning, or even to walk away if your professional judgment on a life safety issue is being compromised. And that's the difference between being a consultant and being a professional with authority.
To help us get a better handle on all these systems, the brief also asks us in Q4 to distinguish between the two main construction manager models, CM at risk versus CM as agent. It says the titles matter less than defining who owns the risk.
That's the key distinction. It all comes down to cost certainty and who's on the hook if things go wrong. A CM as agent is purely an advisor to the owner. They manage the schedule, they coordinate the trades, they consult on the budget, but they do not guarantee the final price.
Okay, so the owner still holds the financial risk.
Exactly. All the contracts with the plumbers, the electricians, they're held by the owner. So if costs go up, the owner pays. In that model, the architect often has a more direct relationship with the owner, and the focus is more on getting the best value.
And, on the other hand, you have the CM at risk model.
The CM at risk does the opposite. They guarantee the final price, the GMP, to the owner. They hold all the subcontracts, and they assume the financial liability if the actual cost of construction goes over that guaranteed price.
So that immediately changes their priorities.
Immediately, they become incredibly risk-averse and intensely focused on cost control from the moment that GMP is set. For an architect, working with a CM at risk means you're under intense pressure to define everything early and to not change a single thing.
And this all ties back to what Q6 says about governance and scope control. Public owners are so rigid about scope changes, not because they're difficult, but to control their political and fiscal exposure.
Change management in the public sector is governance. It's not just a project management task. Every single change order requires a paper trail, funding approval, sometimes even a public hearing. I mean, imagine the political fallout of a headline that says, new elementary school is now 15% over budget because the architects kept changing things. It's a disaster. So as an architect, you have to internalize this. Flexibility, which is normally a designer's best friend, is often the enemy of public governance. The game is won in pre-construction by locking everything down to minimize those downstream changes. Hashtag 1.5, the architect's preservation strategy.
All right, let's flip this around and talk about the positive side of statecraft.
Yeah.
Signal C in the brief is really interesting. It says public procurement is evolving from low bid to best value. So RFPs are now scoring things like social value, community outcomes, life cycle cost, not just the cheapest price to build it. This sounds like the architect's big chance to win on quality.
It is, but only if they speak the right language. The insight here is that procurement is fundamentally a language translation problem. Let's say you design a building that is truly superior. It's going to save the city millions of dollars in energy and maintenance costs over the next 50 years. But if you submit that brilliant design to an RFP that only asks for the lowest first cost, you're going to lose every time.
Right.
You have to translate your architectural intelligence, your durable materials, your passive cooling strategies into the language of procurement. You have to call it life cycle cost savings, long-term risk mitigation, and measurable community benefit outcomes.
The best design loses if it cannot be procured. That's such a great and humbling line from the brief.
It's everything. Let's apply this to the scenario they give us. A public cultural center is being delivered via design build.
Yeah.
The contractor comes in post-GMP and proposes a major cost-driven change. Let's say they want to swap out that custom terracotta rain screen we talked about for a cheap EISS system. The architect needs a strategy to preserve their design authority. What's the tactical playbook here?
Okay, so step one has to be go back to the contract, identify the governing clauses. What did the original RFP say about the quality of the building envelope? Was it tied to a 50-year lifespan? Was there language about durability or the cultural mission of the building?
Exactly. You have to anchor your defense in the legal documents, not in your own personal taste. Then second, you have to translate your design intent into performance requirements. So if the contractor wants to use EIS, the architect's job is to quantify the performance gap.
So you don't say it will look cheap.
You say, this proposed substitution jeopardizes the required 60-year facade lifespan and violates the durability standards articulated in Section 3.2 of the owner's RFP, which will lead to a higher long-term fiscal risk for the city.
And the third step, which is just about protecting yourself, is to document everything.
Document every single decision to protect your professional standing. You issue a clear, formal, written notice to the owner, and you copy the contractor. You state the proposed change, you quantify the compromise in performance, and you state, for the record, that you cannot professionally endorse a substitution that jeopardizes the long-term performance that was promised to the public. See? That's the move. That is statecraft. You're not fighting for aesthetics, you're advising your client on how to manage their legal and fiscal risk.
The final lesson here just feels so unavoidable. Architects who ignore procurement become, as the brief says, decorative consultants.
Yes.
You're just dressing up the box that the contractor's budget allows for. To have real impact, you have to master the contract.
And that really wraps up our tour of the contractual battlefield. We've defined the systems of power that get things built. So now, let's make a sharp pivot. Let's move from the systems of politics to the systems of physics, from the world of RFPs to the world of thermodynamics.
I'm ready. Let's turn to segment 2. Thermal resilience. This isn't theoretical. This is the immediate life and death reality of designing for a climate frontier. So this whole segment shifts gears and reframes the architect's job in the face of extreme heat. The brief labels it a public health issue, an equity issue, and an engineering issue. We're basically moving beyond just meeting the minimum energy code and into this world of mandatory passive survivability.
Yes, the climate reality has forced this issue. A building's ability to handle heat is now literally a matter of life and death, especially for the most vulnerable people in our communities. This means architects need a mastery of thermodynamics that goes way, way beyond just specifying a bigger air conditioning unit. Hashtag TAG 2.1 extreme heat as the new life safety standard.
So talking point 1 in the brief highlights that cities are now treating extreme heat waves like other natural disasters, like hurricanes or floods. Emergency plans are being rewritten to include things like mandatory cooling centers and resilience hubs.
And that completely changes the accountability structure for buildings. Suddenly, how a building performs when the power grid fails is a public accountability issue. And the core challenge is just so simple, but it's devastating. When the power goes out and the AC dies, how does the building itself, the architecture, protect human life? Because we know that prolonged exposure to high indoor temperatures causes organ damage and eventually death.
And that explains Q1, which confirms that passive survivability is now being tested on the architectural licensing exams. It's not some niche green concept anymore. It's a fundamental life safety standard, precisely because mechanical systems are the first thing to fail in an extreme event.
Right. Passive survivability is just a term for the building's inherent ability to maintain a livable indoor environment without power. The typical metric is keeping the indoor temperature below about 80 degrees Fahrenheit or 27 Celsius for at least 72 hours during a heat wave. And to do that, you have to use the architecture itself as the climate control system.
Okay, let's get into the specifics. What are the critical passive elements that make a building survivable in that way?
The two workhorses are thermal mass and natural ventilation. Thermal mass just refers to using heavy, dense materials on the inside of the building, things like thick concrete floors, brick walls, maybe even water tanks. Think of an old stone church cellar. It stays cool all summer, that's thermal mass. It takes a huge amount of energy to heat that material up, so during a 110-degree day, that mass acts as a heat sink, absorbing energy and keeping the indoor temperature stable and much, much cooler than the outside.
So it's like a temperature shock absorber. And natural ventilation, how does that work in tandem?
Natural ventilation is about designing the building so it can breathe. It means having clear strategic openings, operable windows, high and low vents, maybe the central atrium, that allow for cross breezes and what's called the stack effect, where hot air naturally rises and pulls cooler air in behind it. The idea is that during the cooler night hours, you can open the building up, flush out all the heat that built up during the day, and let the cool night air recharge the thermal mass for the next day's battle. If your building can't breathe when the grid fails, it becomes a convection oven.
In Q7 in the brief makes a special point about public buildings. Why do they have to be held to an even higher standard of resilience?
Because in an emergency, they become essential public infrastructure. They are the designated refuges. They're where a city tells its most vulnerable citizens, the elderly, families with young children, to go for safety. So they have to guarantee that they can continue to operate. This means their passive design needs to be even more robust, often with dedicated, heavily protected refuge zones inside, and usually coupled with some form of hardened on-site backup power for emergency systems. A high-performance envelope isn't a luxury for these buildings, it's mandatory. Hashtag tag 2.2 thermal equity and urban form. Now let's shift to talking point 2, which is about thermal equity. This is the social justice dimension that's woven through this entire discussion. We're seeing urban planners mapping what are called urban heat islands, or UHIs, and overlaying that data with socioeconomic maps of income, race, and the age of the housing stock.
And I'm guessing the data is confirming what most of us have suspected for a long time. Extreme heat isn't just deadly, it's profoundly inequitable.
It's brutally inequitable. Q4 asks us to understand what an urban heat island actually is. It's a phenomenon created entirely by the way we build cities. Dark surfaces, asphalt roads, black tar roofs have a very low albedo. That's a scientific term that just means they absorb a huge amount of solar energy instead of reflecting it. All that stored heat is then radiated back into the air, especially at night, which prevents the city from cooling down like the surrounding countryside does.
So in the hottest neighborhoods, which are often older, lower-income communities with very few parks or trees and tons of pavement, the local temperature can be 10, even 15 degrees hotter than in the leafy suburbs. And these are exactly the neighborhoods where people can least afford the AC they would need to survive that heat.
That's the cruel irony. The people living in the hottest microclimates are often in the oldest, least insulated housing with drafty windows, and they're relying on a single, inefficient window AC unit that's going to fail the moment the electrical grid gets stressed. The policy solutions the brief points to are trying to use design as an equity tool. Things like mandating cool, reflective roofs, aggressive programs to increase the urban tree canopy, and publicly funded retrofits for existing affordable housing.
But then the brief throws this wrench in the works. It highlights a huge concern from the Heat Justice Policy Lab. How do you use architecture to reduce heat exposure without triggering housing displacement?
And that is the climate gentrification trap. It is a huge problem. Imagine a city mandates a series of expensive architectural upgrades for all rental properties. Let's say a landlord is now required to do a $40,000 deep energy retrofit on their building. If there aren't strong tenant protections or public subsidies in place, that cost gets passed directly to the renters in the form of massive rent hikes. Or the owner just sells the newly valuable, highly efficient building to a developer, and the existing community gets evicted.
So a policy that was meant to improve people's lives and make them safer becomes a tool for their economic displacement.
Exactly. The architectural solution has to be paired with policy statecraft. Things like rent control, targeted subsidies that benefit the current tenants, or community land trusts. You have to make sure the physical improvements lead to safer, more stable lives for the people who are already there, not for a wealthier group that moves in after them. This is why the brief is so insistent that thermal failure is, at its core, a social failure. You cannot separate the building science from the human impact. Hashtag tag 2.3, structural and material integrity under stress.
Okay, let's get into the raw engineering all this. Talking point 3 is pretty alarming. It warns that engineers are still designing buildings based on historical climate data that basically describes a planet that doesn't exist anymore. Our design assumptions are being exceeded in real time.
We have to get past this idea that heat is just about human comfort. It's about the physical integrity of our buildings. Extreme, prolonged heat cycles introduce entirely new ways for materials to fail. We're obsessed with designing for, wind and snow, but now we have to be just as obsessed with designing for temperature cycles and material fatigue.
The brief lists a few specific types of material failure. Let's start with creep. What is that?
Creep is the slow, continuous deformation of a material when it's under a constant stress, especially at high temperatures. The classic example is leaving a heavy stack of books on a cheap plastic shelf for a few years. You come back, and the shelf has started to sag. That's creep. Well, heat dramatically accelerates that process in building materials like concrete and steel. If a structural beam is constantly exposed to extreme heat, it can start to experience creep, which over time can compromise its ability to carry its load and affect the building's long-term safety.
And then there's the more obvious, but maybe more insidious issue of thermal movement, which is what Q6 gets at. Why do structural engineers need to be so focused on this?
Because the amount of physical expansion and contraction in materials, a long steel beam, an aluminum curtain wall, a big concrete slab, is massive when you consider the temperature difference between a freezing winter night and a scorching summer afternoon. If the engineers don't design generous and well-detailed expansion joints and tolerances to allow for that movement, the building will fight itself. The materials will force that movement on their own.
And what does that look like?
It looks like cracked facades, buckled siding, binding points where things get stuck. Or, worst of all, the failure of the things that are supposed to keep water out, like sealants and waterproofing membranes.
It sounds like a slow-motion demolition. The building is tearing itself apart day after day.
In a way, it is. And this all comes back to Q3 and why envelope design is so dominant. The envelope, your roof, your walls, your windows, is the building's most important filter. If you have a poor envelope, you have massive heat gain, which means you need a massive, energy-guzzling mechanical system to compensate.
Earlier, you mentioned a technical spec from the critique section, a U-value target of 0.25 Wh/K. Can you translate that for us? What does that number actually mean?
Sure. Wh/K stands for watts per square meter per degree Kelvin, or Celsius. It's the U value, and it's a direct measure of how easily heat moves through a piece of your building. The key thing to remember is that a low number is good. It means very little heat is getting through. A standard, minimally insulated wall in an older house might have a U value of 1.0 or even higher. So a target of 0.25 means you're designing a wall that is 4 times better at resisting heat flow.
So if you hit that 0.25 standard, you're not just saving energy, you're dramatically reducing the amount of heat seeping into the building in the first place, which is critical for that passive survivability we were talking about.
That's it, exactly. It's the difference between taking shelter under a flimsy umbrella versus being inside a sealed thermos. And this means you have to master the inevitable glazing trade-offs. Glass is the architect's best friend and the energy modeler's worst enemy. It lets in light, but it also lets in a ton of solar heat. So you have to use high-performance glazing, but you also have to couple it with really carefully designed external shading overhangs, fins, screens to block that high-angle summer sun while still letting in winter light. If you fail that trade-off, you're not designing a building, you're designing a liability.
Okay, let's wrap this segment up with the ultimate design challenge from the Daily Drill. Designing the heat-safe building. The prompt requires a design for a public or residential building that can remain habitable, and they stress the word dignified, for 72 hours with no power during a major heat wave.
This is where architecture really has to step up into this realm of radical resilience. And habitable and dignified are the key words. This can't be some survivalist concrete bunker in the basement. It has to be a functional, safe, and respectful environment. The whole design strategy has to rely on this beautiful integration of passive systems to create that 72-hour safety buffer.
So what are the non-negotiable elements? What would you have to show in that design to pass the test?
You'd have to show a complete synergistic system. First, you need to show maximized exposed thermal mass on the interior to act as that heat sink. Second, you need optimized external shading with calculations showing how your overhangs and fins are tuned to the solar angles to block all direct summer sun from hitting the glass. And third, you needed to diagram the clear, unobstructed ventilation paths that are designed to promote that passive stack effect for nighttime cooling.
And what about this idea of refuge zones?
Right. Even in the best designed passive building, the temperature is going to rise a little bit over 3 days. So the design has to identify specific refuge zones. These would be core areas of the building, maybe on the north side, or areas that are coupled with the ground where temperatures will remain the most stable and the coolest. These zones act as the final safe haven, allowing occupants to gather in the safest part of the building until the power comes back on. It's about ensuring that 72-hour survival window is met without anyone having to resort to desperate measures.
And the final stress test in the brief is the post-occupancy failure scenario. This is tough. An affordable housing project you designed, it meets code, you did everything but fails horribly during its first heat wave. Indoor temperatures are hitting dangerous levels. You're facing a storm of political and professional scrutiny. What's the playbook?
The first step is immediate triage. You have to collect data. You need temperature and humidity logs from inside the apartments. You need to cross-reference that with utility bills and, if possible, interviews with the residents about how they're using the building. You have to diagnose the failure. Is it a flaw in the design, like a missing insulation layer, or is it an operational problem, like tenants not understanding how to use the ventilation system?
And once you figure out the cause,
Then you have to determine the split of responsibility. If it was a genuine design error, you have a professional liability and you need to propose a fix. If it's an operational issue, the building management needs new training and procedures. Then you immediately have to identify passive or low-energy retrofit options, things like reflective roof coatings, external insulation, or adding operable exterior shades, things that can be done with minimal cost and disruption.
and the final piece of this ties all the way back to segment 1, back to statecraft.
It does. You have to coordinate funding and approvals. Retrofits cost money, and affordable housing projects have no extra cash. So the architect has to become an advocate. You have to leverage this public health crisis to go to the city housing department, the public health agency, maybe even look for federal grants, and translate the technical need for a better U value into the civic language of, we need to do this to save the lives of vulnerable residents.
That lesson, that thermal failure, is a social failure. It just resonates so powerfully right there. You can't separate the architecture from its social contract.
You can't. And this whole section really challenges us to think of the city as a thermal commons, where our first priority is architecture that actively cools and protects people in the public sphere, not just the wealthy people inside their privately air-conditioned towers.
We have covered so much ground. We've gone through the 2 central pillars of this mentorship brief. We looked at the necessity of architectural statecraft to, secure the delivery system, and then the absolute necessity of thermal resilience to secure the inhabitants. And both systems, the contractual and legal one, and the physical thermal one, they're both fundamentally about professional responsibility, about managing risk, whether that risk is legal, fiscal, or, most critically, human.
And to just reiterate that core idea one more time, mastering procurement and delivery methods is what gives an architect the real authority to shape systems instead of just reacting to the rules that someone else wrote. And the mastery of climate adaptation, especially thermal resilience, is what's going to define the next generation of successful, responsible cities. Because the climate is only going to get more aggressive in how it tests what we build.
The source material really leaves us with this direct, very challenging question for every architect. If the power goes out, how does my architecture protect life? It forces a real humility. So we want to leave you with this question for your own reflection. If your project achieves stunning aesthetic excellence, it wins all the awards, it looks beautiful in magazines, but it fails its contractual promises because of a poor procurement strategy, or it fails its occupants during a heat wave because of poor thermal design, can it truly be considered a success?
Mastery has to be holistic. It demands that technical depth, that legal sharpness, and an unwavering civic responsibility to the people who will live and work inside what you create.
Thank you for joining us on this deep dive into the architectural insights with KING-KAMBUF. We hope this conversation has armed you with some of the tactical knowledge you need to move beyond just making forms and into the real practice of architectural statecraft.
Until next time.